In this video, we will continue practicing solving real-world problems using matrices. Let's take a look at problem number 5. The Fox Theater charges $23 for adults, $14 for senior citizens, and $9 for children under 12 for the live performance on Sunday afternoons. This past Sunday, the paid revenue was $12,953 for 864 tickets sold. There were 47 more children than adults. Determine how many adults, senior citizens, and children went to the Fox that day. The first thing we need to do is define our variables. That's going to be based on what they are asking us to find. Determine how many adults, senior citizens, and children went to the Fox. I'm just going to use X, Y, and Z. So I'm going to let X equal the number of adults. I'm going to let Y equal the number of senior citizens. And I'm going to let Z equal the number of children. As is often the case, I think we are going to have a money equation and a quantity equation. Money, quantity. Let's do the money equation first. Fox charges $23 per adult. So that's 23x will be the amount of money for adults. They charge $14 for senior citizens. So plus $14 per senior citizen. And they charge $9 for children under 12. So plus $9 per child under 12. Alright, this is all money. So what am I going to set this equal to? Will I set it equal to 864 or 47 or 12 or $12,953? I'm going to set it equal to this because this is money. 12,953. Okay, money from adults plus money from seniors plus money from children equals total amount of money. There's the money equation. Now it's time for the quantity equation. This is the number that indicates the total number of people. Alright, there were a total of 864 tickets. That means the number of adult tickets plus the number of senior citizens plus the number of children. That should add up to the total number of tickets, 864. Now if we have 3 variables, we're going to need 3 equations. So hopefully there's more information here. There were 47 more children than adults. Okay, so children and adults, we're talking about X and Z. Okay, so let me do this off to the side. Let me start off by saying X equals Z. This is a false statement. Alright, on X is adults and Z is children. Right now, this is false because there were 47 more children than adults. Okay, so really Z is greater. So we would have to either add to the adult side to balance it out, or subtract 47 from the child side. Okay, so we know that there are 47 more children, so that I know that this is more. That's why I could do X plus 47 should equal Z. Alright, add 47 to the smaller amount and it should equal the larger amount. Now, we need this equation to be in standard form. Right now I have x plus 47 equals z. But we need the variables on the left and we need the constant on the right. So what I would do is I would subtract z from both sides like this. So that's going to give me x minus z is equal, whoops, not quite there yet. Alright, I've got x minus z plus 47 is equal to 0. Now I'm going to subtract 47 from both sides. So now I have x, leaving sort of a gap for y, minus z is equal to negative 47. So this equation is in standard form. Let's bring it over here. X minus z is equal to negative 47. Is that what we had? Yes, it is. Okay, so now all the x's are lined up, the y's are lined up, the z's are lined up, and the constants are lined up. That puts me in a position to write this equation in matrix form. Let's start with the coefficients. I've got 23, 14, 9. That's the first equation. 1, 1, 1. From the second equation, 1, 0, negative 1 from the third equation. So these are all the coefficients of the variables. So I will call this matrix C for coefficient matrix. Now it is time for the variable matrix x, y, z. But I will call this matrix V for variable. And that's going to equal the answer matrix, which is 12,953, 864, and negative 47. This is the answer matrix, and I will call it matrix A. Since C times V equals A, if I want to find matrix V, it will be C inverse times matrix A. So it's time to put this in the calculator. Okay, let's see. Second matrix, edit menu. Let's do matrix C. This is now a 3 by 3 matrix, so 3 by 3. Okay, 23, 14, 9. So 23, 14, 9. 1, 1, 1, 1, 0, negative 1. Okay, it's all in there. Always quit your way out of a matrix. Now let's enter matrix A. So let's go to the matrix area, switch to the edit menu, and choose matrix A. Matrix A is a 3 by 1 matrix, so we'll make that change. So 12,953. 864, and I believe negative 47. Okay, always quit your way out of a matrix. So as I said, we need C inverse A, and that'll be the answer. So let's go back to the matrix area, but this time we'll stay under names. So I will pick matrix C. If I hit this button, it becomes C inverse. Now I go back to the matrix area, stay under names, and pick A. So I have C inverse A just like I wanted. I will hit enter and get the answer, 273, 271, 320. What was that? 271, 320. Okay, and please understand that this is x, and this is y, and this is z. But in the end, we need to write our answer using words. So 273 adults, 271 senior citizens, and 320 children. Let us do another problem. Lemonade stand. A child in a neighborhood had a lemonade stand where large cups were sold for 75 cents. Small cups were sold for 45 cents. On Saturday, a total of 78 cups were sold for $42.90. Let X be the number of large cups and let Y be the number of small cups sold. How many cups of each size were sold? As is so often the case, we are going to have a money equation and a quantity equation. This is probably the most common type of systems of equations word problem there is. So let's do the money first. Okay, the equation practically writes itself. Large cups sold for 75 cents. Okay, what are the variables? X is going to be the large cup. So large cups sell for 75 cents. So 75 cents per large cup. Small cups sold for 45 cents. So plus 45 cents per small cup. This should equal the total amount of money earned. Okay, so not the 78, but the $42.90. This is a money equation. So of course we go with the money, $42.90. Okay, now let's do the quantity equation. They told us that a total of 78 cups were sold. Alright, this kid was absolutely on fire. So the number of large cups plus the number of small cups had to equal 78. Alright, this kid was blowing up. So that's it. We have two equations, two unknowns. We can solve this. Let's make our matrix equation, starting with the coefficients. So I'm going to have 0.75, 0.45, 1, 1. Okay, that's my coefficient matrix. Now let's go with the variable matrix. So X and Y. And that's going to equal the answer matrix, which is 42.90 and 78. We'll call that matrix A. Since C times V equals A, then the variable matrix should equal C inverse times A. So we will use our calculator. Let's start with matrix C. So second matrix, switch over to the edit menu. Let's do matrix C. Now this is a 2 by 2 matrix, so I got to make that change. Alright, 0.75, 0.45. 1 and 1. Always quit your way out of a matrix. Now let's go back. Second matrix. Again, edit. This time matrix A. Matrix A is a 2 by 1 matrix, so we have to make that change. 42.90 and 78. Okay, so what we need is C inverse A. So we will go back to the matrix area, second matrix. Let's print C by hitting the number 3. We'll hit x to the negative 1 power. Now it's C inverse. Go back to the matrix area one more time. Hit enter for matrix A. That's C inverse A. Hit enter, and boom, there's your answer. 26 and 52. Okay, this is X and this is Y. But in the end, we must write our answer in words. So 26 large cups were sold and 52 small cups were sold. Alright, let's try to squeeze in two more problems. Calculator problem. In 1 week, a math store sold 14 calculators for a total of $1,140. Blue calculators cost $75 each, and silver calculators cost $85 each. How many of each type of calculator were sold? Shocker. There's going to be a money equation and a quantity equation. I bet you did not see that coming. But first we have to define our variables. We're supposed to find how many of each type of calculator were sold. So that tells us what the variables have to be. So there were blue calculators, so I'm going to let B equal the number of blue calculators. And there were silver calculators, so I will let S represent the number of silver calculators. And as we often do, we will write a money equation and a quantity equation. Get used to it, because it happens all the time. Let's start with the money equation. 14 calculators, that's not money. Oh, here comes the money. Total of $1,140. That will come at the end. Blue calculators cost $75 each. So here comes the money. $75 per blue calculator plus $85 per silver calculator. So 85S should equal the total amount of money. This is the money equation. $1,140. So there's the money equation. Now the quantity equation. Somewhere they told us the total number of calculators. So the number of blue calculators plus the number of silver calculators should equal, well, there were 14 calculators sold. So B plus S must add up to 14. And that's it for the setup. Let's go ahead and write our matrix equation. Let's start with the coefficients of these variables. 75, 85, 1, and 1, the coefficients of B and S. These are the coefficients, so I will call this C for coefficient matrix. Our variables are B and S. This is my variable matrix, so I'll call it matrix V. Our answers are 1, 1, 4, 0, and 1, 4. This is my answer matrix. So I want to solve for the variables, obviously. Since C times V is equal to A, then matrix V should equal C inverse times A. And we can just put this in our calculator. Let's start with matrix C. So second matrix, switch to edit, pick matrix C. 2 by 2 is what we want. 75, 85, 1, 1. Always quit out of a matrix. Now let's go back to the matrix area, back to edit, choose A. 2 by 1 is what we want. 1,140 and 14. Quit your way out. Now we want C inverse. So we start by picking matrix C and hit x to the negative 1 power. Now it is C inverse. Second matrix, choose A, and we have C inverse A, hit enter. Boom! 5 and 9. These are the answers. Okay, based on the way our variable matrix is set up, 5 is the value of B and 9 is the value of S, but we can't leave it like that. You must write your answer using words. So 5 blue calculators and 9 silver calculators were sold. My friends, let us do one more problem. Harvest earnings. The feed mill pays a farmer $6,930 for the first delivery, $5,475 for the second delivery, and $8,879.50 for the third delivery. The table shows the number of bushels included in each delivery. Use the table to write and solve a system of equations to find the price per bushel that the farmer received for each crop. Okay, it sounds like this is all money. We're going to have 3 money equations. One equation for each delivery. But first we have to define our variables. We are being asked to find the price per bushel of each crop. So I'm going to use C, W, and S. So that means C will be the price of a bushel of corn, W is the price of a bushel of wheat, and S will be the price of a bushel of soybeans. So with that in mind, we are ready to write some money equations. Alright, so for every, if we multiply 900 bushels times the price of corn, this is the money from corn, plus 540 bushels times the price of a bushel of wheat, that's the money from wheat, plus 360 bushels of soybeans. Alright, this should equal the total amount of money received for the first delivery. Okay, now what did they tell us about the first delivery? They told us that the mill farmer pays $6,930 for the first delivery. Okay, so the second 2 equations are going to follow the exact same pattern, so I'm going to speed up and just follow the same pattern. So 1,125 per bushel of corn times the price of a bushel of corn, plus 150 times the price of a bushel of wheat, plus 225 times the price of a bushel of soybeans. Okay, what's the total amount for the second delivery? 5,475. Okay, and one more time, looking at the third delivery equation, it'll be 860C plus 645W plus 645S equals. Alright, what's the total amount of money for the third delivery? $8,879.50. Okay, so this is our system of equations. We will use matrices to solve this, starting with the coefficient matrix, which will be 900, 540, 360, 1125, 150, 225, 860, 645, 645. All right, these are the coefficients of the variables, so I will call this my coefficient matrix C. Now the variable matrix, the variables in order from left to right are C, W, and S. So this is my variable matrix, and this will equal my answer matrix, which is 6,930, 5,475, 8,879.5. All right, I will call this matrix A. Since matrix C times matrix V is equal to matrix A, if we want to find matrix V, it should equal C inverse times A. So we just need to get matrix C and A into our calculator and produce this expression on the calculator. Alright, so second, matrix. Switch to edit. Choose matrix C. Make it a 3 by 3 matrix. Get to typing. Alright, I typed that in wrong. In fact, I'm just going to type in the rest of these numbers off camera. Alright, here I have finished typing in matrix C. Always quit your way out of a matrix. Now we need to type in matrix A. So back to the matrix area, back to edit, choose A. A is a 3 by 1 matrix, so change the dimensions. And then get to typing. 6930, 5,475, and I'm pretty sure the next one is $8,879.50. Am I right? Yep. Okay, always quit your way out of a matrix. So, as we said, we need C inverse times A right now. So, one more time, we will go back to the matrix area and under names, choose matrix C. Hit the x to the negative 1 power button to make it C inverse. Go back to the matrix area again and choose matrix A, and we have C inverse A. Boom! These are the answers. Okay, 3.2, 3.5, and 6. Okay, I'm writing the numbers this way. Instead of putting 3.2, I put 3.20 and 3.50 and 6.00 because don't forget, this is money. These are prices. So this is really $3.20. Okay, now remember that the way our variable matrix is set up, and we just found matrix V, so that means the top number is the variable C, the middle number is W, and the bottom number is S. But we can't stop there. We need to write our final answer in words. And here it is. A bushel of corn costs $3.20. A bushel of wheat costs $3.50, and a bushel of soybeans costs $6.
On the outside, always looking in, will I ever be more than I've always been? 'Cause I'm tapping on the glass, waving through a window. Can anybody see? Is anybody waving?